Hello, everyone. Welcome. I'm just going to give it a few minutes while we let folks trickle in. Hope everybody, if you're in Philly, get a chance to enjoy this gorgeous weather today. So glad you're here and not outside, or maybe you are outside just listening in. No judgment. But anyway, so maybe we could get started. So my name is Greg Stewart. I'm the coordinator of adult public programs and a museum educator here at the Philadelphia Museum of Art. And I'm so excited to welcome you to Photography and the James Webb Telescope, the Arnold Newman Memorial Lecture. Before we begin, I just want to say that it's with gratitude and humility that the Philadelphia Museum of Art recognizes Philadelphia as part of the Lenape-Honkink, the ancestral homelands of the Lenape peoples. A long history of forced treaties, or broken treaties, forced migrations, and fraudulent agreements such as the Walking Purchase of 1737 displaced many of the Lenape from this land. This museum and our staff strive to understand our place within the legacy of colonization and to act as allies to Lenape people and their vibrant communities, including the federally recognized nations today, the Delaware Tribe, the Delaware Nation, and the Stockbridge-Munsee community. We pay honor and respect to Lenape ancestors, past and present, by committing to build a more inclusive and equitable space for all. So as I said, welcome to Photography and the James Webb Space Telescope. Tonight's talk will really focus on not only the remarkable images this telescope has made, but also considering these pictures from both the perspective of science and art, and how this telescope came to be. And we're also going to look at sort of the broader context of pictures of space and really consider how we are seeing our own humanity reflected in these images of what is otherwise so vast and experiences quite unlike anything else we might know on this planet. And this is the Arnold Newman lecture, as I've said, and so I definitely would love to thank the generosity of the Newman family for their support. The format of tonight's lecture will be presentations from each of our panelists, moderated Q&A with Amanda Bock, our curator of photography, and then audience Q&A at the end. We expect the program to last about an hour. You are in Zoom webinar, so your camera and microphones are turned off, but you can ask questions in the Q&A box as they come up. And questions you really like can be upvoted so they rise to the top. Closed captioning is available by clicking on the CC button in the Zoom toolbar. And finally, this program is being recorded, and we will send the recording to everyone who has registered. So I want to just give a really quick introduction to our speakers in the order that they'll present. So first we have Chris Gunn, who is a photographer who specializes in creating images of science and technology. Based in Washington, D.C., he recently documented the construction of the James Webb Space Telescope. His images have been featured in Scientific American, Wired, National Geographic, and the New York Times. Welcome, Chris.
Thank you. Thank you so much. I'm Chris Gunn. Oh, you're going to talk about everybody.
Thank you. And next we have Dr. Knicole Colón, who is an astrophysicist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. She is the James Webb Space Telescope Deputy Project Scientist for Exoplanet Science. Colón also serves as the project scientist for the Transiting Exoplanet Survey Satellite and for the Pandora SmallSat mission. She grew up not too far from here in New Jersey and is a diehard Eagles fan, so go Birds. Hi, Knicole.
Hi, everyone. Go Birds.
Hope there are some Eagles fans here tonight. Anyway, and then we have Dr. Jennifer Levasseur, who serves as the responsible curator for the National Air and Space Museum at the Smithsonian's astronaut cameras, chronographs, the space shuttle, and International Space Station programs. Her book, Through Astronaut Eyes, Photography from Early Human Spaceflight, looks at the cultural significance of astronaut photography. Hello, Jennifer.
Hi there, and I'm waving from not too far away over by the Philadelphia airport.
It's a very local program tonight. Sometimes it's not. And then last but not least, we have our moderator, Amanda Bock, who is the Lynn and Harold Honickman Assistant Curator of Photographs. Hi, Amanda.
Hi.
Okay, so with that, I'm sure you don't want to hear any more from me. I'm going to turn it over to Chris for our first presentation.
Thank you. So, hi everyone, I'm Chris Gunn, and from 2009 to 2021, to the launch of the James Webb Space Telescope, I served as the lead photographer, documenting basically every aspect of the mission. So, photography goes hand in hand with NASA's missions, because we photograph every aspect of the build and integration and testing of spacecraft. We photograph every washer, every bolt. We document every wrench turn. And this work falls under the broad category of scientific and technical photography. But Webb was a little different because it was an agency flagship mission. It was the largest observatory, largest telescope ever placed into space with the largest mirror. And it gave us an amazing opportunity to connect with the larger audience, the larger global audience that was interested in the build of this telescope. And I'm going to share some of my favorite public images with you right now. So in this first image here, there's no flight hardware. It's all test images, but it's the first public image that NASA released as a James Webb image. It's inside of NASA Goddard Space Environmental Simulator, which is a cryogenic chamber that was built and designed, or it was designed built and designed in the 50s, but it was redesigned for Webb to be able to go down to the cold temperatures that Webb would see in space. And what you see here is a simulator that basically tested the concept of Webb to make sure that it would work at those cold temperatures optically. And it was really amazing to be in that environment. And the photograph, the individuals are actually putting together this test hardware, which is what you see right here. So all of the instruments were actually put through the rigors of this sort of cryogenic testing. And here you have an engineer, AC Herrera is his name, who's testing a part of the MIRI instrument. This is one of the 4 cameras. So Webb had 4 cameras, 4 instruments that were going to go into space. And this is a component that flew on top of MIRI, the MIRI instrument, the MIRI camera. This image shows you all 4 cameras, so all 4 instruments, which were the mid-infrared camera, the near-infrared camera, the near-infrared spectrometer, and the fine guidance sensor. So those 4 instruments flew inside of that sort of black box that's inside of the larger white cube. Here they're doing a test. It's what's called the gravity sag test, where they're actually spinning those instruments to see how they're going to operate when they're tested later during a vibration test. Now we're getting to one of the most famous parts of Webb, and that is the mirrors. So all of the mirrors were delivered to all 18 of Webb's gold mirrors were delivered to NASA Goddard in these silver containers, and they all made this sort of trip through the halls of NASA. One of the things that I tried to capture with my images was the human element that was involved in all of the building and design. So capturing these sort of live images as things were happening was really important to me to tell the story. So each and every one of these images was pushed out to the public through our social media team. This is an image of the first gold mirror that was delivered to Goddard. And this is each one of the 18 mirrors actually went through an inspection process, and this is part of that inspection process. The inspection actually took place inside of the largest clean room in the known world, which is at NASA Goddard Space Flight Center. I included this image because it shows some of the testing that was done on a test mirror that shows how they might go about cleaning the telescope. This image actually, I mean, it was just, once I created it, it was just one of the prettiest images I had made. So that's not an actual flight mirror, but they're trying to figure out a process as to how they might clean the mirrors in the case that they were dirty. This was called, they're basically shooting dry ice onto the surface of the mirror. They never had to use this process, by the way. So now this is an image showing the structure without any mirrors. So this is the flight structure of the telescope. Each one of those 18 holes there is where a mirror would go. And if you look closely down in the right-hand corner, you'll see two men that are pulling some blinding there. And that basically gives you the scale of the telescope. Now, the 18 mirrors all were assembled onto or integrated onto the telescope structure, rather, with this robotic arm. And this was a test of that process, not on the telescope itself, but a test structure called the BESTA. And basically, you have a guy underneath and a guy on the side, and they're trying to make sure that this process is going to line up, that the mirrors won't be damaged, that the structure won't be damaged. And then they would move on to the telescope itself. This is another view of that on the left, and on the right, you have a structure called the Pathfinder. And the Pathfinder was basically the telescope structure without the wings. And that Pathfinder structure went through all of the testing, or basically all of the testing that the telescope would eventually see. After the integration of the telescope, this was the very first contamination inspection that was performed on the telescope of all the mirrors after they were uncovered. And the video team and I were able to get into the clean room and document that process. I love this image because it's the very first time that I was able to see one of the wings folded back on the integrated telescope. And it gives you a peek at how the telescope would be folded up so that it would fit onto a rocket for its eventual launch. Another one of my favorite frames and of the full telescope, the full mirror, fully deployed mirror. This was after a successful test where they aligned all the optics, and it's not posed. These men were in there, these engineers were in there inspecting something, and I happened to have my camera and have some lighting set up and captured this amazing shot. Like I said earlier, it was really important for me to capture the human element of the build and testing. This is a typical day inside of a clean room, and there might have been 30 people in there, all watching this tent being lowered over the telescope. This was so that they could go out and they could do some vibration testing. They had to leave the clean room and take a mobile clean room with it. So capturing this process was something that we did every day, and just being able to capture it in this level of detail was really important. One of my favorite frames here, this was done after the telescope returned from vibration testing, and I was sitting around waiting on someone to basically call my name and say, hey, Chris, we need a shot of this, or we need a shot of this. And what I did was set up one of my cameras and do a 2-minute exposure, and basically captured all of the movement of the contamination control engineers that were doing the inspection. And just one of my favorite frames. So I traveled with the telescope everywhere that it went. The first place that we took that NASA traveled with the telescope to was Johnson Space Center. for cryogenic testing. It was so large that it couldn't fit inside of any of the other chambers. And this is chamber A. That's with the door open. And this was during the actual cryogenic test. This next image here was at Northrop Grumman. Once the telescope completed all of its cryogenic testing, it was flown to Northrop Grumman for more testing. This was a typical day. This image here captures the sort of hands-on work that the blanket team did. More blanket inspections. Getting close to the end here, but I have to show this, one of my favorite images of the full deployment of the optical system, basically, under its own power. So you have the primary mirror, which is the gold in the background, and reflected in that, you have the secondary mirror, which is on the boom. So this was a test of the entire optical system. And if you look in the center, that is where the instruments receive their light path. And there's a cover on that, and that's a lens cap, which was taken off just prior to shipping. Fully deployed telescope. Okay, that's my alarm. And I'm almost done here. This is the fully deployed telescope with the sun shield, showing the optical portion of the telescope and the sun shield. And this image here is the actual final full deployment of the 6.5 meter primary mirror. This was the last image made at Northrop Grumman. And this was the telescope being lifted out of its shipping container in French Guiana. And these last two frames, these last two images, the last time I saw Webb on Earth was the first images after the encapsulation in French Guiana, the encapsulation into the nose cone of the rocket. And that second image was from one of my remote cameras capturing the launch on December 25th, 2021. All right, thanks for listening, folks.
Thanks, Chris. Yeah, I'm gonna take it from here. And
okay, great.
So I'm Knicole Colón again. I'm a scientist at NASA's Goddard Space Flight Center, and I have the pleasure of being able to actually use the telescope that we just saw in these beautiful photographs. And now we can take beautiful photographs of space with this telescope. Now, the first slide I have here is just a graphical representation depicting broadly what JWST is observing in the universe. And the short answer is that it's observing basically everything from nearby planets in our solar system and further beyond out to the distant early universe where galaxies first form. And so what I wanted to do in a few photographs that the telescope has taken already is show you just a few representative examples of the science that we can get out from the telescope, but specifically using these beautiful images and how it's really, there's a piece of art to it in terms of getting the images in the first place. So I wanted to start with one of our nearby neighbors, if you will, our neighbor Neptune in our solar system. Now, this is a zoomed in, if you could imagine, JWST has zoomed in on this planet real close to take an image. And what we're seeing here is Neptune in the middle, and then you're seeing faint rings around the planet. And then also you see a couple dots as well. There's actually 6 dots, and these are moons orbiting around the planet Neptune. Now, to give you a point of reference, this image it's really difficult to take this type of image because Neptune is actually 30 times farther from the sun than the Earth is. So Neptune's orbiting in this really dark, remote region of the outer solar system. And it's also not that large. It's only about 4 times the size of our own planet Earth. So it's small, it's faint, it's distant. And so, it's really difficult to capture such an image. But JWST is very powerful telescope, and we are able to see this planet, and not just see it, but see details that we haven't been able to see, actually, in some cases, in more than 30 years, like the rings that you're seeing around Neptune. The last time these were detected was actually when Voyager 2 did a flyby 30 years ago, more than 30 years ago, 1989, I believe. So that is, telling us again how powerful, we've been waiting a long time to use this powerful telescope to get this beautiful image. But it's not just about the images, we can learn from them. We see these dust rings around the planet. We see bright spots and streaks on the planet's atmosphere. And these are actually methane ice clouds that are in the atmosphere of Neptune. And so when we study planets in our solar system, for example, with this telescope, we can study their weather patterns, their composition, and relate it back to our own planet. And again, see how diverse our solar system is. But this is, a nearby neighbor. We can also, of course, use a telescope to study much further away objects. And this is actually an image of a star that's about 25 light years away. To put that in context, light travels at a finite speed. So it took 25 years or so for the light to get to our telescope from this object. It's relatively close by still in the grand scheme of the universe. But the cool thing here is, again, it's like we've zoomed in on this one star with JWST. And with the power of the telescope, using its infrared wavelengths of light as well, at wavelengths that we cannot see with our human eye, we are able to discern these dust belts around the star. And you might notice in the middle of the star, it looks like, a black hole. It's not actually a black hole, but it's just that we blocked out the bright star to see the faint dust rings around it. And so we're basically, it's like imagining, again, with a photograph, you're stretching the contrast in such a way so you can see these faint features. And the inner dust belt that kind of looks like a J, that's actually something that we'd never seen before. JWST looked at this star, and that's really exciting in the first place. But this is also exciting because these dust belts occur because we believe that they're debris left over from when planets were forming. So we're now seeing a planetary system that's been forming, and we can again learn from this to understand how planets form and evolve over time and compare them again back to our solar system. So that's super, exciting that we can do that. But now if we zoom out further, this is and one of the, I'll call it iconic images now that came out when shortly after JWST started science observations. But I wanted to show this because this again goes to scale and now resolution of the telescope and contrast again. Now, well, in the previous images, we were zoomed in on one planet and one star, but now we've effectively zoomed out to I say a larger region of the sky, but it's still just one small piece, again, in the grand scheme of things. But you can see many, hundreds of stars in this image, actually, each point source. But then you're also seeing these really dense ripples and clouds of gas and dust. And this is where stars are forming, actually. And they're forming, probably new planetary systems as well. So new planets are forming. And so you could take this image and zoom in and see, more detail and structure and learn about jets and outflows and how, different stars form in clusters and all of that. And so it's very informative, but it's also very beautiful. And that just shows you, again, the power of this telescope to show us how we can have basically informational art almost. And this is, again, while it's much further away than Neptune and the star I showed on the previous slide called Fomalhaut, this is still within our galaxy. This is, so our galaxy is composed of billions of stars and gas and dust. It's all gravitationally bound to each other. But now if you look further out in the universe, that's really one of the main reasons JWST was developed, was to study the early universe and get beautiful pictures like this, where you're having it's almost information overload because every bit of piece of information here, every object is interesting. You're seeing stars that are really nearby with these diffraction spikes, but most objects behind those stars are galaxies. And so each point almost, or each blob, each worm-looking thing is actually a galaxy with millions, if not billions of stars. And you can again see just there's so much detail in these images, and we can learn so much. And there's physics though too, because all those, stretched out worm-looking shapes, they're galaxies, but light has been bent by a massive galaxy or galaxy cluster. And light from even further in the universe has been bent, and you see streaks as a result. And this is known as gravitational lensing. And so this telescope is capable of using, its powerful cameras and resolution and different filters to get all this data so that we can see these details. And so I did want to point out, how do we do this? And the idea, we don't get these images as is. They're not transmitted to Earth looking so beautiful, unfortunately. But the data is actually transmitted to Earth in the form of bits. And then the bits are transformed into black and white images, and as shown on the left here. And then what we can do is, we stretch or rescale the images to reveal their contents, and we can get, a black and white image like in the middle. But then what we do is we take an image at multiple filters, like, different wavelengths of light, a blue filter, a red filter, all kinds. And then we can stack them to get a composite image like shown on the right-hand side. And so basically all the information is there, in space. The telescope sees it, transmits it to Earth, and then we just have to pull it out of the images. It's already there. But we have to go through the process of getting all the information out so that we can end up with these gorgeous photos that you see. The last thing I wanted to say was that we also get information beyond the images. So these are all stunning. And what we can do though, is when we observe in different filters, we can actually break down images, basically separating light into a rainbow. And when you do that, we get something called a spectrum. And so for, let's say, a star in one of these images that I just showed, if you use the right type of camera or instrument on the telescope, you can get a spectrum of light and really break down, and you get what looks like these bumps and wiggles in this white line here. And that actually tells you what that gas is made of, or that, cloud of dust is made of. This is actually though a spectrum of an exoplanet. So this is real JWST data here. And so in this case, you're seeing wiggles that are due to water emitting light, or carbon monoxide, methane, things like that. And so we take these images and photographs, but then we can use them to gain information about literally what is the universe made of. So it's a really powerful and beautiful telescope, and then it provides us with, the beauty of the universe in return. And so with that, I want to hand it off to Jennifer, and as our last speaker. I will stop sharing.
Thanks, Nicole. That was great. And it's a great lead into what I'm going to talk about, which is a little bit closer to home. This will be a little bit, I think, hopefully familiar to everyone. Maybe not quite everyone, but I'm going to bring it back to our local neighborhood. So quite literally, the neighborhood in which some of you might be sitting right now might be on the screen. And this is something I like to sort of do in order to kind of reframe our discussion here. We're in our local neighborhood, and the local neighborhood in this case, of course, is Earth. And this is something that JWST can't show us. It's the look back at Earth. And that's something that I've studied quite a bit in my work, and looking at what astronauts are looking at and how much the last few decades of human spaceflight in particular have shaped our understanding of our own Earth. And of course, have encouraged us at the same time to think about the bigger picture that we are part of. So what our eyes show us, which is not what JWST shows us, as Nicole was just talking about, there's a filtering process and a processing of data that has to happen in order for that information to be visible to us. It's not visible light, it's wavelengths beyond our vision. And so what astronaut photography allows us to do is to think very seriously about what we can see. You know, we can kind of compare that. And so depicting space travel is an important part of how we understand space. The astronaut images that come down to us from different missions over the course of the last 60 or so years have really shaped our understanding of our planet, of who we are, how we fit within the universe. But this is something that we need. We need this human perspective in order to connect with the images and to connect with photography and to connect with spaceflight. The images, of course, like I said, that are gathered as data from JWST require human interpreters. They require someone to take that information and make it available to our eyes. And those tools are very different from the tools we're familiar with, because the tools you'll see that astronauts use, of course, are probably quite familiar, especially to someone like Chris, who uses these tools in his daily work. But the basic principles of visual imagery that Nicole has already alluded to, things like size and scale, contrast, they're part of the calculation that goes into how astronauts are going to do their work as well. But they're not something like artistry, which can be a part of the calculation in processing an image. That's not necessarily a part of the calculation for how astronauts are going to do their work. It tends to be a byproduct, though, anyway, just because our Earth is, frankly, an incredibly beautiful place. But there's no way that we can give any of this, you know, anything I'm going to say here is not giving any preference or priority to images that have a human component or are taken by human hands. But they are really, this is really just a great opportunity to kind of compare the two and the things that we can see and can gain from having the ability to put ourselves in the shoes of someone, say, like this astronaut, which happened to be Nicole Mann on a recent mission. This is from ISS Expedition 68, and she took her astronaut selfie in February of this year. And so what you can see from an image like this is not only some kind of information, you can see the Earth sort of behind the helmet, you can see the Earth reflected in her visor, but you can see the rigors of space flight on the scratches in the mirror of the mirrored surface of her face shield. You can see the technology that's used in space and some of the work that has to go on. You can see her spacewalk partner just above the camera there in the reflection of her visor. And so this really gives us a lot of insight into the work that we are not participating in, but is really vital to how we go about participating kind of virtually or vicariously through the work of the astronauts. I always try to put this in context, knowing that the audience is not necessarily a space audience. You're probably big fans of art. It's always good to kind of step back from this and make sure that you can understand the framework of astronaut photography in this specific case, but also spaceflight and human spaceflight in general. So early astronauts, the first astronauts in space, Yuri Gagarin and Alan Shepard, did not take cameras into space. They had movie cameras photographing them during their flights. But this really wasn't this sort of big impact moment for photography. That begins really with John Glenn on his mission in February of 1962. And we'll see some of his cameras in a moment. But he carried some cameras, handheld cameras, the kind that you would get and he got in a drugstore. And something that you'd be familiar with as a regular camera user back in 1962. But really what reshapes the trajectory of how we understand ourselves in the context of our local neighborhood of the Earth-Moon community or neighborhood is really this image, which is of Ed White on Gemini 4 in June of 1965. This is the first time we really see an astronaut in space. He leaves his spacecraft, he goes on the first American spacewalk, and they're able to photograph him from the spacecraft. And so his mission commander, Jim McDivitt, took this image, and this really does reshape the path in which NASA goes even with its images of spaceflight. Of course, there's lots of images we could talk about from the Apollo missions from 68 through 72, and they add tons of layers to our understanding, and I'll talk about a few of them in a minute. But the thing to really kind of grapple with is that as of this week, as we've just launched some new human beings into space for the first time, we've surpassed just over 600 human beings in all of our human history to be in space. And that's a really staggeringly small number of people who've gotten to have this experience. So it really is through these visual depictions, these photographs and movies in some instances, where we really get to kind of connect with the experience. It's a really vital piece of that. And I would argue the images from JWST are also our way of connecting with our bigger environment, our bigger universe, really. So tools are a really important part of this work. JWST is a tool. The Hubble Space Telescope is a tool. They reveal the bigger universe around us, but smaller tools, ones that might look a little more familiar, are really important to the story of human spaceflight. The two on the left are the handheld cameras that John Glenn took on his flight. The very iconic Hasselblad, sort of at the center of the screen, is the camera that the Apollo 11 astronauts used, and really was in use from the Gemini program all the way through the early part of the ISS program. And so this is sort of where photography is in the period where we really recognize astronaut photographs as being these sort of really monumental things. The camera on the bottom I'll briefly mention. This is the camera. This is the exact camera that photographed the first touchdown on the moon. This is the movie camera that was pointed out the window of the lunar module as it touched down during Apollo 11. And one that's maybe far more familiar is the Nikon here. This is the Nikon camera that John Glenn used on his follow-up flight back in 1998 on the space shuttle. So this is the emergence of digital photography. And so this is really what begins to connect my story with the sort of Hubble and JWST stories, where you've got astronauts able to use digital photography in a much simpler and much more rapid way, so we can capture lots and lots of images rather than relying on the film cameras that had been used prior. And there's lots of other things to show about spaceflight. It's not just showing the Earth or the moon. It's also about showing the activity of the astronauts. I know one of the ways that I always understood spaceflight was through IMAX films when I was growing up in the 1980s. And I was able to then, strangely enough, in my career, collect the first IMAX camera used in space that really brought some of those monumental movies of the 1980s to all of us. So these are things that are able to immerse us as the viewers at home in spaceflight. Why do I not mention what's being used today? Well, that's because everything that's up in space has stayed there and it's still in use. And so we don't even have some of these things in the collection at the Air and Space Museum in Washington, D.C. But this shows you they've got a huge variety of cameras at their disposal, huge variety of lenses at their disposal. So they can see from the very broad things, the wide angle, all the way down to the very powerful high resolution things. So size and scale, these are, some things ways to compare what's been done in the past by people and how we can see it, and how that may look in a different size and scale. And that's one of the hardest things to grapple with about JWST images, is just the enormity of what we're seeing. And I think that deep field that we saw from Knicole is probably one of the most sort of hardest to wrap our brains around, is just how much is in there. You can look at just a tiny piece and see a galaxy, and it's really quite amazing. So on the left here, we have an image from probably one of the famous images from the Apollo era. This is the image that was captured on Apollo 17 by the Apollo 17 astronauts as they left Earth going towards the moon. And I'm showing it here as it was framed on the roll of film that they used. It's always been cropped, but really what I want to get at here is how you're just seeing Earth, which is only 8,000 miles in diameter, approximately 8,000 miles in diameter. You're seeing it with an 800 millimeter lens on a Hasselblad camera at about a distance of 21,000 nautical miles. Compare that to what you see on the right, which is Stephan's quintet. It's in the constellation Pegasus, and it is 290 million light years away. The distance across this image is about 620,000 light years. And just remember that light can travel about 5.8 trillion miles per year. So this is really on a scale we cannot really imagine in our brains, when our scale, even to look at the Earth, is kind of out of whack a little bit, because you can figure out in a sense where you might be or what it's like to be in a very small portion of that image on the left. But to think about how that fits into the image on the right, it's really just outside of our sort of mental capacity to understand size and scale. Then there's contrast and color, and that was a big consideration when taking photographs during the Apollo era. They did take black and white photographs, but the color photographs are really what change our understanding of what the moon is in particular. So we see the moon as a very bright, silvery object in the sky because there's so much light from the sun bouncing off it. But when you get up close to it, it's actually more of a brownish color. In fact, some areas were even more reddish, and this soil you can see depicted here is actually considered orange when it's viewed at a microscopic level. And you can see the astronauts using tools during their mission to actually show the color. And the images are color corrected. The flight films have all been digitized, and this is one of those digitized images. But you can see there's this really high degree of contrast, even in a color image, where you see the shadow of the astronaut on the right. So this is the astronaut, one of the other astronauts. There's two astronauts, one taking the image and one seen in shadow. And so there's this great variety of color that we don't otherwise think that we would get when we're looking at an image of the moon. And on the right, we've got something that I've always thought was really spectacular. I think many of us did. This is the pillars of so-called pillars of creation in the Eagle Nebula. It was famously captured first by the Hubble Space Telescope in 1995. It became one of Hubble's signature images. And that's one of the things that's also great about the abilities of scientists, is you can actually point your device back at a similar spot and see it in even greater detail. And that was part of what Knicole was getting at, is that now with the ability of the infrared imaging on JWST, you can actually see the stars that are embedded in these dust clouds. The stars that are being born in what sort of is called stellar nursery. It's just this amazing place where there's tons of star activity. So to be able to see that in detail now, and at this, and with these colors included in it, it's just really beyond spectacular. So is this really sort of an artistic endeavor? Is what scientists, astronauts are doing, are these artistic endeavors? And I would say absolutely, because nature in and of itself is very beautiful. The image on the left is of a location in Mauritania in East Africa. This image was taken in this was taken in May, just a few weeks ago. But this location in Mauritania has been repeatedly photographed by astronauts, in part because of its contrast color, the sort of elegant, sort of swirling nature of the Earth itself, these features on the Earth. One of the places astronauts really love to photograph is the Caribbean, because of the colors, the difference in color that happens with the water against the land and the islands. And so it is this really beautiful location. And so they see the great beauty that's in our Earth, and they depict it in these photographs. And you can look at then what's next to it, which is the Southern Ring Nebula, which is 2,000 light years away. And this was captured, it was one of the first images released from JWST last year. And you can see how this sort of great range of color is possible when interpreted through the filters that Knicole mentioned. And so there's this great thing. And what's really interesting to me about these two things is that these two images, just to kind of wrap up, is that you could actually go to the location on the left. You could go to Mauritania and see this in great detail. And like I said, hundreds of people could possibly have seen it from space. But there's this, sort of really this huge, like enormous concept behind what's on the right that's really quite beautiful and interesting for us to look at, but is really sort of outside of our range of sort of relatability in terms of photography. So I'll wrap what I had to say there, and we'll go, I think, to questions.
Thank you so much. It was so great to hear from all three of you. Again, my name's Amanda. I'm the assistant curator of photographs at the museum. And the real genesis of this talk is that, like almost everybody I've met, I was incredibly taken with these photographs on seeing them. And I wanted to know more, both as a photo historian, curious about how they were made, and also really intrigued by the enormous impact that they have had on people. I think, between the regular news cycle, I think there's a good meme game going with the telescope pictures too. And of course, many other ways they've kind of infiltrated the popular imagination in a really quick and meaningful and deep way. So I wanted to start with a question about where we find ourselves in these pictures, because as Jennifer was saying, a lot of the images from space that we find ourselves relating to, or that have also kind of fallen into this iconic status, are ones where there's a human referent, right? So there's an astronaut planting a flag on the moon, or an astronaut backed by planet Earth, or of course the blue marble that we saw earlier. But the degree to which we've all been really entranced by these pictures, I feel like we must be finding the human in these too. And so I wonder if you think that's true, and if so, why? And if not, why not?
I'll jump in just to say, I know there's a scholar who really looked at this really intensely in relationship to the Hubble Space Telescope images. So the one up here is, kind of a good version of that, is that one of the things that inspired sort of the look of those Hubble images, and it was quite an intentional thing. Her name is Elizabeth Kessler, and she wrote a wonderful book that really compares and sort of it processes the images as a piece of heritage, essentially related to painters of the 19th century, especially the American West, the Hudson River School painters. And that there is this, in this image, I think is really evocative of that feel of, there is a familiarity to the pattern of color here. There is a sense of like, this could be a mountain range in a really, sort of Western landscape, or like the one I pointed out in Mauritania. You could see yourself seeing this in an earthly context. And I think that's where there is this really interesting conjunction between art and science that's happening to make these images a little more digestible, basically, that there is something that feels familiar about them without being, like I said, anywhere within our realm of understanding in terms of size and scale. But you can look at them and view them and enjoy them as sort of art in their own way, in part because it's inspired by art.
And I mean, there is this real artificial divide between science and art that we often grapple with between our two disciplines. So I wondered if any of you wanted to speak a little bit about where you find creativity in your work and how that informs either what you're doing, Chris making photographs of the telescope itself, or Knicole working in the lab, or Jennifer working as a curator.
So, I didn't have an analog to go by when it came to creating images of the telescope that sort of were a little elevated beyond just the scientific and technical or engineering photographs that I made on a daily basis. So when it came to images that were pushed out to the public, I did look for inspiration in a variety of places. I spent a lot of time watching science fiction, reading science fiction, to sort of get in the mindset of portraying something that people had never seen before, like you would in a science fiction movie. So I started to incorporate lighting. I used a lot of symmetry to be able to evoke a feeling in the viewer that they were seeing something that was special. And some of the lighting was a little tricky because we had to figure out how to light the reflection in the mirror and not the mirrors in order to pull that off. But it all worked out in the end, and I think we have a good record of the build of Webb.
Yeah, and I'll add to the creativity part. You know, as a scientist, actually with the telescope, what we do is we propose objects for the telescope to look at, and then they get reviewed and selected. And so when we propose to observe a certain star or galaxy or something, we often have to come up with, you know, logical but also creative reasons why we want to observe that particular object in the sky. You know, it fascinates us for some reason. You know, there's something interesting about it that we want to learn to answer some bigger question. And so a lot of it's about physics, you know, sure, and logic, but there is a lot of creativity to come up with an argument, you know, as to why we want to study this object over all other objects, you know, right now. And so it's a good mix in our daily lives of what we do as scientists, is bringing in creativity to decide what the telescope is going to look at in the first place.
And as a curator, one of the things that I have to think about is how I take what's in front of me, the history, the technology, the cultural resonance and all of that, and kind of blend that into a story that one could put on walls inside a museum. It's really a huge challenge to create an exhibition that has a point of view, that makes an argument, just like say an academic article would or a book would, but also to then pull in objects, images, and other things to kind of really bring that to life in a way. It's one of the biggest creative challenges we have at the museum, is in particular trying to answer the thing that we know people want most when they come to our museum, which is they want to know what space is like. What is it like to be in space? How does it feel? They want an emotional connection to the experience. And that could be a scientific component that can have lots of different components. And so thankfully we have lots of different exhibits where we can break down that, that answer that we give them. But how do we connect them to something? And so we use a lot of things like immersive environments in particular, which we've found to be really successful. We can't give them a sort of Disney World type experience where you're in a huge space. It's just not, you know, we're a government facility. We can't spend, exorbitant amounts of money to make something that you would pay, we would pay for, first of all, because, visiting the Smithsonian doesn't cost you anything. But to give that and make it feel real and to have an emotional response is really challenging, just to think about creatively. And so we think a lot about what is the design of this space going to be. And I'm working on an exhibition coming up in a few years as part of our renovation project that will really try its best to immerse you in what is it like to live and work in space. What is that physical space like? What is that like to be away from home? What is it that can make space home for human beings? And so a big part of what the museum does now is really try to think creatively about that.
So I want to ask two more questions, and then I want to leave a little bit of time for audience questions because I see there's quite a pile up in the Q&A box. I wanted to talk about something that the four of us talked about a little bit last week, relating again to aesthetics. So I think, Chris, it was you who said there's no up in space. And so that has me thinking a lot about more about these images and how they look. Jennifer, you've already touched on this a little bit by likening this to landscape, which took a little bit of the wind out of my question, because I actually have notes in here about 19th century landscape painting as a referent for these pictures. But I know, looking at the images of, the kind of raw image and its translation through filters into what we see before us, like I'm struck by the fact that I don't think these images would have such a deep cultural pull if they were presented in any other form besides this kind of finished color image. And I guess I'm curious to hear a little bit more from you about whether aesthetics is a concern in the presentation of these images and how that gets thought through at NASA, or if it's something that's not on your mind at all when these pictures are generated and then released to the public.
Well, I can start by noting that, yeah, there's, a small army of experts, who work to craft these images as they come down, because there are 4 different instruments on the telescope, and they're taking, and they all have many different filters. So there's a lot of different data coming down, a lot of different objects. The telescope's observing 24/7. So we're getting a lot of information. And so, yeah, there's a lot of effort and care, honestly, put into deciding how to assign, different colors to different filters, because I mentioned we don't see these wavelengths with the human eye. So, to the best of their ability, they assign a blue wavelength to the blue infrared, if you will, and they kind of do assign colors accordingly to reflect as best we can, if we had infrared eyes, what might we see, right? And so, yeah, there's absolutely a lot of attention to detail, because the more detail, like, yeah, of course they want to make them beautiful, but the more detail that they can pull out too helps the scientists. So it is both, for everybody that their process is just a great benefit. So yeah, I just wanted to point out that there's, a lot of people who very carefully pay attention to all these details, and they work with scientists to make sure that these images are, representative of realities if we had infrared eyes.
My last question, to kind of wrap it up, and is really to think about these images in the context of landscape a little bit more. So I think, Jennifer, in your book, you talked a little bit about how there are some analogies to make between the way that we photograph space and the way that we photograph our own world, and specifically about the way that exploratory images are often bound up with ideas of control or ownership or taking of ownership, right? So, for example, I think the photographs in the American West that were made by Europeans coming to essentially take that land away are kind of images that depict a kind of ownership. And likewise, I think, we've talked a lot about the planting of the flag on the moon. Like that is really the epitome of claiming something for yourself to a degree. But for me, I think the telescope pictures feel really different. I mean, for one, they're in the public domain, and the telescope is made broadly accessible. And I also wonder if a little bit of that isn't that it's not just documenting a physical place, but it's also recording time. But I wondered if anyone on the panel has thoughts about that. Like, do these images depart from the kind of history of photography and control and ownership, or do they have more in common with those ideas than I think they do?
I think of them, I mean, there's certainly a sense of compatibility, I think, with what we know about image, about the past of photography. there's a commonality there, but yeah, we're moving farther and farther as we move farther away from the ideas of control and ownership, like you mentioned. The difficulty that we can really have with accessing the early images from, say, 19th century expeditions of, say, a place like the Grand Canyon, which is one of the things that kind of comes to mind when I see an image like this with the big oranges and browns and things like that, is sort of something that's very geological. There's definitely a different spirit to them. There is not this, they are less about, one of the words that has crossed this boundary, there are two of them, and it makes it really challenging because they get used so often, are the words frontier and pioneer. They're so laden with, so much history, especially something like the frontier, that it makes it really difficult for spaceflight to have its own sense of independence, and images of spaceflight to kind of really be independent of this. So there are some really unusual connections that get made through this whole story that I think we're gradually seeing ourselves moving away from, and certain terminology, just even in something as simple as not using the word manned space flight anymore. We're gradually moving ourselves away from thinking about these as a sense of control, and looking them more, I think, much more as a sort of very expressive, independent point of view. And that's, something that you see even in the work of the astronauts, is there is an ability for them to not be so tightly controlled by the photography. There were about 20,000 images that came during the 1960s throughout the American space program. Now 20,000, that could be taken in a matter of a week. And so that sort of ability to be very flexible, the digital realm has really opened up those opportunities. They can photograph absolutely anything they want. Usually guided by people who are interested in certain things, but it feels very similar to how Knicole described what the JWST team goes through in thinking about, okay, what are we going to do next? There's a sense of independence there too that I think definitely is very separate from what we saw sort of prior to, say, 1961 or so.
Real quick, I wanted to just say I don't see this as conquest or control at all. Really, I just see it as an extension of humanity's. Humanity has always looked into the heavens, and technology is enabling humanity to look farther and farther into the heavens to see more detail. So I just see it as a melding of resources and our desire to peer into the heavens to see possibly our origins. So
well, this is an amazing discussion so far. I want to make sure we have so many questions in the Q&A that we can't possibly get to all of them, so I apologize for that in advance. But I want to, especially since we're over, I just want to make sure we at least get to a few of them, if everybody's okay, for those who want to stick around, because there's some great questions here. So one of the questions I'm seeing multiple times, I think this was inspired by your presentation, Chris, is that the hexagonal shape around the mirrors. I think people are so curious about that. I love Sarah Carpenter's description of them being organic, which I think is really interesting when we think about these around human scale. Yeah, maybe this be for Chris or even Knicole to sort of talk about that hexagonal shape and what that does for the telescope.
it gives the telescope the ability to have a 6.5 meter mirror that can also fold. So it's origami inspired. And so the way the development of Webb sort of worked, or the creation of Webb, 30 years ago, there was a decadal survey, and they decided that the best thing to follow up on from Hubble would be to send an infrared observatory up that had a gigantic mirror. And how do you make that? How do you get that mirror to fit onto an available rocket. So they had to go through these designs, and what worked was this hexagonal mirror, because they were able to put 18 mirrors and fold it up in the effective space of that 6.5 meter mirror. So that shape, that geometrical shape worked for that. And I saw in the Q&A, someone else asked if the mirrors were gold. They're beryllium with a layer of gold. Beryllium because it's light and because it doesn't change shape when the temperature fluctuates, and we need that. And that layer of gold was chosen because it reflects infrared light the best. So
one question I'm seeing in the comments too is around movement, you know, thinking about how all of these galaxies, all these stars, and the telescope itself are all in constant motion. How does the James Webb Space Telescope or the Hubble or any of these space telescopes for that matter stay locked on target on objects long enough to get an image?
Yeah, I can jump in. Yeah, so the telescope it's orbiting about 1 million miles away from Earth. And Hubble actually orbits around the Earth, so they're very different parts of space. But either way, we basically, I don't say every telescope, a lot of telescopes, JWST, has reaction wheels that basically you can point the telescope, and they're all spinning wheels, so you can point the telescope at, let's say, a star, galaxy, whatever, you know, some point in space. And yeah, the telescope's moving. It's moving actually around its orbit at the second Lagrange point, but then it's also like moving in parallel to Earth around the sun. But because it's such a precise system, you know, it's precisely built, the engineering has worked fantastically, that we are able to use those wheels to keep the telescope locked on, essentially, to a target for hours at a time. Sometimes it's only a few minutes that we need. Sometimes it is hours. You know, I think one of the longest observation stares has been over 24, maybe 36 hours, something like that. Actually, for an exoplanet observation. So, yeah, it's able to use. There's, you know, these instruments basically that facilitate stable pointing, and a lot of telescopes do that. But with Hubble, I will note that because it orbits around the Earth, it can point at something, you know, for a long time as well, but it also gets occulted by the Earth because it's orbiting. So it can stare at a star for hours, but it will have gaps in the data because Earth gets in the way every 90 minutes or so. Yeah.
Thank you. And I think maybe we'll just have one more question. And I love this as a kind of way to wrap up, because I think this is maybe a nice conclusion. It seems that these space photos have a lot in common with the history of traditional photography, as we've been talking about, in terms of the sense of awe and curiosity in seeing our world. I'm wondering if anybody wants to comment on that sense of awe or curiosity.
I would love to, in that there are a couple of really wonderful examples of astronauts, and I think, you know, you might find this with JWST images or Hubble images as well, is that the beauty of the world around us and the universe around us have inspired, in particular, astronauts, a sort of sense of a creative expression. They need to really interpret through their artist eyes what they've seen from space or in space. And the two of those that really come to mind the most are Alan Bean, who flew to the moon on Apollo 12, and Nicole Stott, who flew on the space shuttle and spent time on the space station. Alan Bean, when he returned, he had been interested in art. He'd been sort of sketching and drawing and things for years. But when he came back from his Skylab mission, really plunged into a lifelong career as an artist. And so he took his visions, his understanding, his experiences, and put them into these very impressionistic versions of what he saw. He'd even take photographs that he had taken and then kind of reinterpret them as pieces of art. And Knicole has created likewise an entire career filled with artistic expression. She calls herself the artistic astronaut, I think. She's done projects sort of painting spacesuits, these mock-up spacesuits in a variety of colors. But the thing that she did that was really probably one of the most wonderful expressions of this is that when she went and spent time on the space station, she had a specially made set of watercolor paints with her. And she painted from a photograph she had taken, but something she could actually go and look at as well if they passed over at the right time. She painted this really beautiful location in the Caribbean. And it was just a very small painting, something like 6 by 8, very, very tiny. But that was on display in the museum for a while. And it was just this really weird sort of intersection of all of these ideas all happening in one specific piece of art that I just absolutely adored. So I encourage everybody to look at it. And it's really, I think, kind of what we've been getting at is there's this, you know, this somewhat unknown, I think, and underappreciated aspect to what goes on in the work of scientists and astronauts, and it is really quite a beautiful thing to be able to see.
Yeah, anybody else have any comments on awe and curiosity?
I mean, sorry.
Go ahead. No,
I
you
was
go
just
ahead.
gonna note that, you know, when I was younger, I had images from the Hubble Space Telescope posted on my wall, you know, and that inspired me and that and science fiction just inspired me, you know, to seek out this beautiful world of, as Chris put it, you know, looking in the heavens, like what is out there, right? And what can we see? And yeah, it's just, so I was definitely, you know, it was a sense of awe back then when I was younger, and it's still that way every time we get a new image like this one, truly.
That's great.
And real quickly, I mean, I had a telescope as a child before I had a camera. And, you know, I like to think of the fact that Galileo is credited with, you know, sort of inventing the telescope. And that was in the 1500s, 1600s. And just not too many centuries after that, we've thrown a massive observatory into space with 4 cameras that can peer through dust. So it's like we're continuing to do the things that humans do, but at a faster pace, using you know, more technology. And I think we'll continue to do that until we're able to travel at the speed of light.
Nice. Well,
this is as close as we can get to that.
yeah. Well, thank you so much, everyone. This has been really fascinating. You're getting so much love in the comments. So, you know, thank you everybody for speaking. Thanks to Knicole and Chris and Jennifer. Thanks to Linnea West, who's been doing a lot of the behind the scenes work, and our captioner, Brooke. Thanks again for the Newman family for graciously supporting this lecture. And thanks to all of you. Just by showing up today for this talk, you're supporting the museum. We want to give an extra thanks to anybody who might have donated to tonight's program, or to anybody who is a member and are supporting us that way. And our next talk is the Rose Susan Hirschhorn Barron Lecture, Almerida on Judith Joy Ross, and that'll be on June 1st at 6 p.m. So hope everyone has a lovely night, and thanks again.
Thank you.
Thank you.